Thanks everyone, I'm here for Factory One. We help manufacturing companies save money by saving energy. We all live in a manufactured world. Everything around us comes from manufacturing. Manufacturing is a $13 trillion global industry. It consumes a quarter of our water, half of our energy, and virtually all of our natural resources. But there are problems with manufacturing. It contributes 38% of our annual CO2 emissions, and it also consumes a lot of energy. 30% of the input cost of manufacturing is energy related, and that's rising. And we know there are supply side issues. There are also demand side issues caused by increasing automation and drive for shiny new products. Imagine if we could save just 5% of that energy. In Australia, the cost of energy to manufacturing is $26 billion a year. 5% is $1.3 billion, and it's the equivalent of taking 300,000 cars off the road annually. At Factory One, well, actually before I say that, manufacturing, just like you and me, gets a bill every year for energy, and you pay the bill. So energy is treated as an overhead. There's no idea of where the energy is being consumed. You can put meters around your factory, you still have energy as an overhead. You've just got finer detail. It's not all just about energy. At Factory One, we take energy and convert it from being an overhead to a direct cost. We take meters at a machine level. We combine it with PLC SCADA data for production, actual production data, and we combine it with ERP data on costing and routing. So we can give you energy by product, by shift, by machine, whatever you want. We then separate out the other resources like compressed gas and the HVAC so that we can start to target improvements. It's not about big data, it's about smart data, being able to understand the data in the domain context of manufacturing. We've run pilots. Now this is old school stuff, I'm told, but this is from our old pilots where we can show you scorecards, we can show you comparisons down at the bottom, we can show you energy cost by machine, by product, and we also give prioritization matrices to help focus on the hotspots in manufacturing. We've run 4 pilots in research stage, and we've published the University of New South Wales on some of these, saving up to 50% of energy in those cases. And now we're going into commercialisation, and we've put together, I think it's a pretty good team. There's me there. I've got experience in manufacturing and industrial engineering. We've got Jared and Niv, who have built 4 companies in the past and who've built Raven, which is the underlying software that we're using. Moss Cady, who's one of the co-founders of Britta, is a director, and then Sami Kara, who you heard earlier today, is our scientific advisor. The future for us, well, we're self-funded, but we've also put in for a CRCP application for commercialisation with the University of New South Wales. We're looking right now for commercialisation pilots. We want to work with commercialisation pilots to tune our beta. We'll continue to do research because energy is really just the beginning of this. We have plans for 30 clients in 18 and growing that to 120 by 2019, and we believe we can get almost 10 million in 3-year ARR over that period. When I say we're looking for partners, we're also looking for partners in consulting, energy, in the ERP space. So we've had discussions with Microsoft, SAP, and I'm about to get the hook, and Deloitte's, but we'd like to talk to others as well. Thank you very much, everyone.
Thank you.
I'm just getting out of your way.
All right, time for our judges to ask questions. Thank you.
Thank you.
By combining the metering data and that from energy with ERP, what's at the actual outcome of that? Does that send a light bulb off in the factory owner's mind? What happens?
Yeah, so the problem at the moment is you get a bill and it's all one bill for the whole factory. I used to pay the bill for our manufacturing site. It was $2 million, and you just pay it and you treat it as an overhead, so there's no idea of where you can make improvements. Once you combine actual production output with machine level data, then you can understand the cost per unit, the cost per machine, and the light bulb is in things like that prioritization matrix. What machines are using a lot of energy while they're idle? What machines are using energy that are not contributing to production? What machines should you not really focus on because they're not consuming that much? So it's, yep.
Thanks. Yeah, really interesting play, and it seems like a huge market. How do you get, so is part of your model understanding which machines are not running efficiently? And if so, how do you get the data to know what's working well and not well? And so is there a question of scale? How do you gain scale?
So scale is something that we thought a lot about. To get the data, we put meters on machines. So we put wireless meters. They're non-invasive, so you just clip them on around the inputs to the machines. They're wireless, so they feed back to a gateway. And we're implementing meters that we've chosen. So there's no upfront CapEx question or choice of meters or whatever. It's then all up through the cloud, so it's scalable in that sense. The onboarding is the critical part for us in scaling, and that's the thing that we're focused so much on.
Thanks. So how's your commercial model arranged for this? I mean, you could see risk sharing working, virtually eliminating the waste. So what's the model there?
So risk sharing was an early idea, but the problem is we can show you what to do, and then something else might be a priority and you decide not to implement it. So we've done a lot of work, but for no outcome. So it's out of our control. The model we've got is a price per meter point, so that it's scalable depending on how big your factory is, how much data you need to get. It's a price per meter point, and it's a subscription service for the SaaS.
I guess so. Then drilling into that, it's very much based on waste elimination. And once you've done it, is it a single point in time so that you would install those devices and sensors, get the data, make the factory more efficient? How do you achieve long-term annuity in that?
So there's two questions in that. The first one is, yes, it's about waste, and we want the mental model for people to be, my bill each year is $2 million a year. I'm paying you guys, $20,000 a year to do this. That's a good self-funding project. So that's one thing. The other thing is on the long term. Absolutely right. I've saved some energy this year, but now I've got something else which is a priority. Energy is our starting point, but once you start getting meters in there, you can do benchmarking, you can do cross-company benchmarking, you can start to get into other areas of machine reliability and so on. Energy is a huge opportunity, but to provide that longevity, you have to you have to give people a reason to keep coming back to it. So it's feature-based. We've also been thinking about how you make it part of their usual, like ENGIE reporting. So the energy reporting has to be done to governments.
Thanks.
Okay, thank you very much. Big round of applause for the factory.